Okay, what we're going to have a look at today are two things: mechanical advantage and velocity ratio. If you had a look at the book this morning, you should have read up on those two things, and you'll have realised that they're both just ratios. They don't have any units. So mechanical advantage then is when any kind of machine, and this is a simple machine, it's a crowbar. When this crowbar is put under the brick here, the brick obviously weighs about 2 kilos, which is about, I don't know, let's call it 20 newtons. So there's probably 10 newtons load on this end of the brick. By me applying just a couple of newtons to this end, pushing it down, I'm lifting 10 newtons. So the ratio is 10 newtons to 2 newtons. So the mechanical advantage is 10 divided by 2, which is 5. So it's the load divided by the effort. Okay? So that's mechanical advantage. The next thing is what we call velocity ratio, and that's how much distance the effort travels compared to the distance travelled by the load. And generally in most mechanical systems you want the effort usually to travel a greater distance than the load. There are certain exceptions to that, for example in gearboxes on cars where you're in overdrive and you want the distance travelled by the load to be further than the effort. But in most cases it's a situation like this where this end of the crowbar is moving through a much greater distance than the brick is going up and down. So this distance here is about 150 mil. And this distance here is about, say, 10 mil. So the distance of the effort is much higher than the distance of the load. So that would be 150 divided by, say, 10. So the velocity ratio of the crowbar is 15. All right. Another example is a car jack. Let's make sure I've got that in shot. Just hold on a minute. Yep. Car jack is used obviously to lift heavy items up like a car, and a car can weigh anything up to, I don't know, the corner of a car can be, say, up to 1/4 of a ton, depending on how big your car is. So there's your car on top. This is obviously a toy car. And in reality, of course, the load on the jack is going to be hundreds of, if not thousands of newtons, depending on the vehicle. And the mechanical advantage is very high because you've got this lever here that's going to turn the screw. And for every revolution of this jack, of this screw, the jack moves up. But you can see that the jack is moving up very, very slowly compared with the circumference of this lever. So the circumference of this lever must be at least, I don't know, 1 metre or more. So for 1 metre movement of this input, I'm getting millimetres of movement on this jack. So the velocity ratio of a jack is very high, and also the mechanical advantage is quite high as well for a jack. Alright, so that's another example of a machine that has a high mechanical advantage and a high velocity ratio. So I'll do a second clip with some calculations on there. So take a look at those. Thanks very much. Bye.